started. Okay, so this week we are one of the many types of equations you're learning how to solve, the radical equations. And most of the time you only solve ones that have a single radical. Sometimes you solve and it has more than one radical, but most common is if you have just one. So that's what I'm going to go over. So first off, what is a radical equation? So in week 1, in section R.3, we learned about the square root symbol, which is also called a radical. And then in week 3, section 3.1, we learned how to simplify radicals. So we've done some stuff with these already. What's really important from week 3 is the rule that if you have a radical, it cancels out the exponent. And what we'll be doing here is that this also works in reverse, where if you have, you can also do the exponent on the outside of the radical, and that can kind of cancel it out and get you whatever is inside. So that's what we're going to be kind of doing here, is we're going to be taking the sort of the alternate way of the radical symbol, where you take, if you have like a square root, you're going to square it to cancel it out. It's just the same rule. It's just that you can interchange where the exponents are. And that is because a radical can be written as an exponent. And so you're just basically multiplying exponents here. So you can, change the order of multiplication. That's the commutative property of algebra. So if we have an equation and it has a radical with a variable inside it, it's called a radical equation. So you have to at least have a radical, and you need to have a variable inside it. That's what makes it a radical equation. So when you're learning all of these different types of equations, you need to be able to identify what type of equation it is, so you know what the proper steps are for solving. So that's how you identify these types of equations. So our goal is to get rid of that radical, and we're going to raise both sides to an exponent, and that will cancel it out. So if you have a square root, you're going to square both sides. If you have a cubed root, you cube both sides. Now, sometimes this does give us what's called extraneous solutions, and these are, you will get numbers that, when you're solving in this way, they seem to work, but if you plug them back into the original equation, they actually don't work. These tend to pop up when you're raising things to an even exponent. So you always have to check your answers with radical equations. Just like rational equations, which are fractions, those are also a type you always have to check your answers, because sometimes you'll get answers that don't work. When we've been solving quadratic equations or linear equations, that does not occur. So it's not as important to check your answers, but it's super important for radical equations. And you also want to look out for if you have an even radical or even root equaling a negative, because you can't, that's impossible. So there's no solutions, because when we're solving these, we're not looking for getting imaginary answers. So all of our answers are going to be real numbers. We don't have to deal with complex numbers with these kind of things, unless we ended up having to do a quadratic formula kind of thing. But for the most part, we're looking for real numbered answers. So the steps when you're solving one of these, and this would be a good thing to put on like a note card, so that way when you recognize radical equation, pull up these steps. You want to rearrange it, start your solving, and try to get the radical part by itself. And you don't want to have a coefficient in front of there. So if there's a number in front of your radical, you need to divide both sides by that number first. So you do your adding, subtracting, and then any division if you need to, and then you have your radical by itself. Then you figure out, is it a square root, cubed root, what is that index? And that's the exponent that you're going to put on both sides. So a square root, you square; cube root, you cube; fourth root, you take to the fourth power. Then that's going to give you an equation. This equation will usually end up being linear or quadratic. And so then you need to solve a linear or a quadratic equation. So you're following the steps for solving those types of equations, which is why we learned those first. And then you have to check your work in your very first equation that you were given, not the one when you got rid of the radical, but the one with the radical symbol, to verify that your answers all work. So I'm just going to go through, I'm going to start simple, and then we'll work our way up to more complicated ones so you can see how this works. And most of the time, we only really see these with square roots. So most of the time, we're just going to be squaring both sides. So on the left here, we have the square root of y equals 7. And we already have that square root by itself. So that's already isolated. So what we need to do is square both sides. So we need to cancel out the square root by squaring both sides. So whatever you do to one side of the equation, you always have to do to the other. So the square root and the square cancel out. So we're just left with y. And then we get 7 squared, which is 49. So that would be our answer, but we need to check just to be safe. So we have the square root and we plug in 49 for y. Does that equal 7? Yes. Now the square root of 49 can give you 7 or negative 7, but we're looking for where does it equal 7? So it works. So we get one answer here, and we didn't get any extra solutions here. We just got this one answer, and it works. So all we had to do was square both sides, and then you have your answer. These are actually a lot easier to solve than maybe a quadratic where you have to take the square root. So I think these are a lot nicer actually than some of those other ones we've done. Now let's take a look at our second equation here. We have the square root of x plus 2 equals 8. So we need to get the square root of x by itself. So I have this plus 2. So to get rid of that, I need to subtract 2 from both sides. So I need to get that on the other side. So that will give us the square root of x equals 6. So now I'm just like I had in the first problem here, where I've got a square root equals a number. And to get rid of the square root, you square both sides. So we're going to square the left and the right. And so the square root and the square cancel, and you're left with x. And then 6 squared is 36. And then you want to check your answer in the original problem. So we had the square root of x, and we're saying x is 36, plus 2 equals 8. And whenever you check your solutions like this, like if we're taking the square root of 36, we always assume the positive, the principal square root. So if we wanted the negative sign, we'd put a negative in front of there. So we always assume the positive. So the square root of 36, the positive would be 6. So 6 plus 2 equals 8. And that is true because that gives us 8 equals 8. So we've just verified that x equals 36 is indeed a solution. Are there any questions so far? Okay. So now we're getting a step up here. These are going to be more complicated because now we have more things inside the square root. So on the left, I've got the square root of 5y plus 1 equals 4. So I'm going to just rewrite that. And we do have the square root by itself, so we still square both sides. Now, the square root and the square still cancels, and what we're left with is everything that was inside the square root. So now our left side is 5y plus 1. And then on the right, 4 squared is 16. So now we have a linear equation that we need to solve. So I need to first subtract 1 from both sides so that I can get the 5y by itself. So that gives me 5y equals 15. And then we can divide both sides by 5 and get y is equal to 3. Now I'm going to show you how you can use some technology to check your answer here. So I'm going to bring up Desmos. It is a wonderful resource. Just want to make sure that it's... So we're going to use the scientific calculator, not the graphing calculator. And I want to check my answer 3 into this original equation. So I'm going to have the square root button, and then it's 5y, which is 5 times 3. So 5 times 3 plus 1. And then you can see, okay, we're wondering, does that equal 4? Well, it says that equals 4 here. So this is how you can check your work is, you can use this calculator to just kind of type it in and then double check that it does equal the right side here. So 5y plus 1 square root equal 4, yes. Oops. Are there any questions on this example? Okay. So let's take a look at the one on the right. We've got 4 equals the square root of 8 plus 3a. And then that minus 1 is outside of the square root. So notice that's not, it doesn't have the line underneath it, so it's not part of the square root. So I need to get the square root by itself, so I need to add 1 to both sides so I can get that away from the square root, because the square root part that we want is just this right here. We don't want that minus 1. So we get 5 equals the square root of 8 plus 3a. So now to cancel out the square root, you square both sides. So that gives us 25. And then whatever's underneath the square root is what we're left with here. So the 8 plus 3a. And so now we've got this linear equation to solve. So I need to subtract 8 from both sides. Which I believe is 17. So that gives us 17 equals 3a. And then we divide both sides by 3. And this is going to give us a fraction for our final answer. 17 over 3 equal to a. That's, we don't want to divide that out because then we have to do some rounding. But we can check our work. So I'm going to bring up Desmos here. And so let's just get There we go. Okay, so we're checking again that this equals 4, but we're going to put in the right side this time. So I've got my square root, 8 plus 3 times a, and a is 17 over 3. So I'm going to put parentheses there, and then 17 over 3, and make sure that's still inside the square root. And then I have to make sure I'm outside of the square root to type my -1. So notice that my line is not over the -1. If you didn't leave and you did -1 and you weren't outside of the square root, you would see the line is still over it and the line is not over it. So you have to make sure that you hit your right arrow to get out of it, just to make sure that you're typing in exactly, you know, what you want here. Make sure that where things are where they belong. That line really does make a difference. And you can see that equals 4, which is good because that's what the left side here equals 4. So that means that our answer works and we didn't get any extra solutions. Any questions? Okay. Now here are some that are not square roots. So we've got a cube root on the left and a fourth root on the right. So if you do a whole bunch of square roots, you don't want to get just into the habit of always squaring because you don't. It depends on what kind of radical it is. So here we've got the cubed root of 2x minus 5 minus 1 equals 1. So I still have to get the radical part by itself. So I need to add 1 to both sides. So that gives me the cubed root of 2x minus 5 equal to 2. And now to cancel out a cube root, you cube both sides. So instead of a 2, we're now raising each side to a 3 for the exponent. And so that will cancel out the cubed root, and you are left with 2x minus 5. And then 2 cubed is equal to 8. So you want to make sure that you've got the right numbers here. Where I see people make mistakes is they'll do 2 squared instead of 2 cubed. So you want to be very careful that you're doing the right exponent. So now we're going to solve. So I'm going to add 5 to both sides, which gives us 2x is equal to 13. And then divide both sides by 2. And we get another fraction here. 13 over 2. So we're going to check our work again using Desmos because it saves time. So we have a cubed root here that we're entering in. So you use this button right here with the N, and then that puts your cursor right here where you can enter 3 to make it a curved or cubed root. And then you can click inside here, and we've got 2, and then times x. X is 13 over 2. So I'm going to have my parentheses, fraction 13 over 2. And then the minus 5 here is still inside the radical, but the minus 1 is outside. So I have to hit my arrow over 1, and then I can get the minus 1. So that's the left side that we have here. And we want to see, does that equal 1? Yes, it gives us 1 on the right. So our left side equals the right side. We successfully checked our answer. And so we know that this is the correct answer here. Now let's look at the one on the right. We've got the fourth root of x plus 16 equals -4. So the first thing here is we've got an even root equaling a negative, and that tells us that there is no solution. But you can get that same answer by solving. So we will also go through solving to show you how you can do the solving process and get the same answer. So if you didn't notice that, and not everybody does, then when you start solving, you want to raise both sides to the fourth power to cancel out the fourth root. So that will give us x plus 16 equals, and then, I don't know, negative 4 to the fourth power, 256. So now we're just solving for x, so we're going to subtract 16 from both sides. And we get x equals 240. So now let's see what happens when you check your work. So we're going to have the fourth root. So we're going to have the fourth, and then inside there we have x, which is 240, plus 16. And so you can see that gives us positive 4, but we needed it to equal negative 4. So when you check your work, it doesn't check. It doesn't give you the same number. And that's how you know there's no solution. This is what's called an extraneous solution. We solved, it gave us an answer, but it doesn't actually work in the original problem. So that's what's called extraneous. So I'm going to just, when you check and you take the fourth root of 240 plus 16 and you're checking, does that equal negative 4? You get 4, and that doesn't work. And so maybe I'll do that x in red. This is extraneous. And that means it's not our solution. And so that's how we know there's no solution, because the one solution we got doesn't actually work. There any questions? Okay. Now these are going to take more steps. So all the ones that we've done, like I was able to do 2 on a slide because they're not too bad. When you have a variable inside a radical and a variable outside of the radical, these you tend to end up with quadratic equations. And when this happens, you also tend to end up with extraneous solutions. So you want to really watch out for these. So we've got a variable inside the radical plus a variable outside the radical. This tends to get us a quadratic, and it tends to get extraneous solutions. And these are the type that you encounter more often, where you'll have variables inside and outside. What I generally tell myself is I say, okay, if when I solve I end up with a quadratic and I only have one, like a linear inside my radical, then I should only have one solution that will work. That's the general rule that I have not had disproven, but I don't think it's like a theorem or anything like that. But that's how it's always tended to work out for me. So I am positive that we're going to get 2 solutions and only one of them will actually work, just from the nature that this is going to give us a quadratic, and we should only have one answer because there's a linear inside the radical. But we'll go through and verify this. So we need to get the radical part by itself. So we need to first move the minus w to the other side. So we always do our adding or subtracting first. So I'm going to add w to the right side. So that's 2 times the square root of 3 minus w equals w. And we want to get rid of the number in front of the square root, because if you don't, it makes things kind of messy. So we are going to divide both sides by 2. And I'm going to just, have this fraction here, and I know it's going to look kind of messy, but we're going to have the square root of 3 minus w equals w over 2. So now I've got the square root by itself, so I'm going to square both sides. And that will cancel the square root on the left. So we're left with 3 minus w. But on the right, this is why we have to go back to the rules of exponents. We square the w, so we get w squared, and you square the 2, so you get 4. So we end up with this 3 minus w equals w squared over 4. And see, this is where the quadratic comes from, is because we had to square both sides, and we ended up having to square that w. So now we are solving a quadratic equation, which means we need to get everything on the same side. But the first thing I'm going to do is to get rid of that over 4, because let's get rid of fractions. Just a whole lot easier if we don't have fractions. So we can multiply both sides of the equation by 4 to get rid of the fraction there. And that will give us 12 minus 4w equals w squared. And so now I want to get everything on one side, and I like to have a positive w squared. I just like the squared part to be positive. So I'm going to add 4w, and then I'm going to subtract 12. And that will make 0 on the left, and then we have w squared plus 4w minus 12 on the right. So now we've got this quadratic equation to solve, which is why last week you guys learned about solving quadratic equations. This is one that can be factored. So I'm gonna go up here, and when we factor this, we get w plus 6 times w minus 2. So 6 times minus 2 gives us negative 12. 6 plus minus 2 gives you 4. And so we set each factor equal to 0. So I have w plus 6 equals 0, w minus 2 equals 0. And then you solve for w, which will give us w equals negative 6 and w equals 2. So we have 2 answers, but we should only have 1. So we are going to check both of these answers. So I'm going to bring up Desmos, and we need to check them in this original part right here. So I have 2, and then the square root of 3 minus, and then w here is going to be negative 6. So I can just put that in parentheses here. And then outside of that, we have minus w, so minus negative 6. And you can see that that gives us 12. We want to get 0. So when we're checking, this doesn't work. It doesn't give us 0. It gives us 12. So this w minus 6 is not a solution that works. It's extraneous. But we should also check the 2 just to be safe. So everywhere I had negative 6, it's 2. That's our other answer. And so you can see we had 2 times the square root of 3 minus w, which is 2. And then outside of there, minus w, which is 2. And that does come out to 0. So we have one solution, which is w equals 2. The other solution that we got doesn't actually work in the original problem. It just is an extra solution that pops up through the solving process. Are there any questions on this example? Okay, so moving on. Here we've got the square root of y squared minus 8 equals y plus 2. So this is another one where we have a variable inside the radical and a variable outside of the radical. This is going to give us a quadratic when we're solving. In this case, we should get no extraneous solutions. We should end up with 2 solutions because inside the radical is a quadratic. So that's the general rule that I use to determine if there's going to be extraneous solutions or not. So inside this one was linear, so we should only have 1 solution. Inside this one is quadratic, we should have 2 solutions. So both of the answers we find should work, and we will check to verify. So we already have it solved, so we just need to square both sides. And so on the left, when we square, we cancel out that square root, we get y squared minus 8. On the right, you need to FOIL. So because we have y plus 2 times y plus 2, we're squaring that whole thing out. I see a lot of people here forgetting that you have to go through FOIL, and they tend to forget the middle term. So when you multiply this, you get y squared plus 2y plus 2y plus 4. So you get y squared plus 4y plus 4. And I see a lot of people saying y squared plus 4. So you have to still follow all of the things we've learned before, and we are squaring a binomial. And so there is a shortcut formula for that, a special formula, or you can go through FOIL, and we get y squared plus 4y plus 4 here on the right. So now I'm looking at this and I'm like, oh, actually, this is not going to end up as a quadratic. We'll end up with 1 solution here because the y squareds here are going to cancel out. So initially when I looked at the problem, I thought, okay, we should get, a quadratic here, and we do, but it just so happens that things cancel out for us. Because if I subtract both sides by y squared, it's a terrible y. The y squareds completely cancel out. And so we're left with negative 8 equals 4y plus 4. So you can have your initial thoughts about a problem and look at it and say, okay, this is what I think is going to happen. But you never know as you start the solving process. So now we're solving for y, so I need to subtract 4 from both sides. And so negative 8 minus 4 is negative 12 equals 4y. And then divide both sides by 4, and we get a single answer here of negative 3. And I do have enough room here, we can check this by hand. And then we can also check it on Desmos. So we have, when we check it, we have square root of y squared, so that's negative 3 squared minus 8 equals, and then y is negative 3 plus 2. So negative 3 squared is 9, so we get 9 minus 8. And then on the right, negative 3 plus 2 is negative 1. Now, 9 minus 8 is 1. We're going to get the square root of 1 equals negative 1. And square root of 1 is 1, so we get 1 equals negative 1. And the only solution here didn't work. So we got an extraneous solution. And so we actually have no solution here because this negative 3 doesn't work. So there is no solution. So initially I said at the beginning, okay, this is probably, these types of things, you tend to get extraneous solutions here. I initially thought, oh, we probably have 2 solutions here. Then we solved and our squares canceled out, so we just had the linear, which gives us 1 solution. But then when you actually check your work, that solution doesn't actually work in the problem. And we can use Desmos to verify this. So we have the square root of y squared, and y is negative 3, and minus 8. And so the left side gives us 1, and then on the right side we have y plus 2. Y is negative 3, so it's negative 3 plus 2. And you can see the right side gets you negative 1. So the left side and the right side are not equal. And so this is not a solution. Are there any questions on this example? All right, so I've got one more. And it's another one like that where we have a quadratic inside our radical, and then we're going to form a quadratic outside. So we've got the square root of b squared minus 5b minus 8 equals b plus 7. So we are going to square both sides. And just like before, the b plus 7 squared is b plus 7 times b plus 7. So you need to FOIL that out, and that gives you b squared plus 14b plus 49. So you can verify that on your own. You can go through the FOIL process. So when we square both sides, we end up with b squared minus 5b minus 8 equals b squared plus 14b plus 49. So just like the other example, the b squareds here are going to cancel. So I'm going to subtract b squared from both sides, and those basically completely disappear, which makes this linear. So we end up with minus 5b minus 8 equals 14b plus 49. So now we're solving for b, and I like to make my variables on the left. So I'm going to subtract 14b from both sides. And that's going to give us negative 19b, then minus 8 equals 49. And we're going to add 8 to both sides. And this will give us negative 19b equals 56. Nope, 57. Let me just double check that on a calculator so that my mental math is not wrong. Yeah, 57. And then we need to divide both sides by negative 19. So I don't think that divides. I'm going to just check that out. Oh, it actually does. So good thing I did on my calculator. It does actually come out to a whole number. And we get b equals negative 3. So now we need to check to see if this is, is this an actual solution or is this extraneous? So on the left side, got b squared, so that's going to be negative 3 squared, minus 5 times b, which is negative 3, then minus 8. And on the right side, we have b, which is negative 3 plus 7. So as we go through, on the left, negative 3 squared is 9. The negative 5 times negative 3 is 15. And then I have minus 8. And on the right, negative 3 plus 7 is 4. So 9 plus 15 minus 8 is 16. So we get the square root of 16 equals 4. And when you take the square root of 16, you get 4. So this does work. So in this case, we did not get extraneous solution. We got a number that actually does work in the equation. And if you wanted to double check this with Desmos, we have to do the left side and the right side separately. So the left side, I can basically type in what I did when I plugged in negative 3. Make sure everything is still within the square root, so that gives you 4. And then on the right side, negative 3 plus 7 also gives you 4. So the left side equals the right side, and you've checked your answer. Are there any questions? Okay, I'm not hearing anything. This was my last example. So that's solving radicals. I think they're actually easier than some of the other things that we've been solving, in some of these other weeks. And just as a reminder, you guys do have your midterm this week, which does cover weeks 1 through 4. So it does include solving radicals. There will be a question on solving something like this on the midterm, but it's not going to be like the super complicated ones where you have, it's not going to be kind of where we have a square inside the radical. It should be a square root one with a linear thing inside the radical. So it shouldn't be like tons of work, but you will have one of these on the midterm. So since you guys don't have any more questions, that's it. Thank you for coming. Hopefully the time change didn't mess you up the end of daylight savings time. I noticed that when I logged into the computer at 6 today for my office hours, it said the live was going on, and I'm like, no, it's not. And I realized that my little widget must have changed the time because of daylight savings time. So even though I had put in 7 o'clock, apparently it changed it to 6 o'clock. And I'm like, oh no. So, yep. So thank you guys so much. And I'll see you guys next week. Take care.